All right, thank you everybody. I hope you enjoyed lunch and are ready to jump into the last portion, afternoon portion I should say. We have several sessions lined up for you of our symposium. We're gonna kick this off with a keynote speech from Sharon Megdal. She's the director of the University of Arizona's Water Resources Research Center and a professor of environmental science. Her research aims to bridge academic and non-academic communities through water policy and management, education, and engagement programs. Sharon's applied research projects include analysis of water management, water policy and governance, groundwater recharge, and transboundary groundwater assessment. In 2020, she was awarded the Warren A. Hall Medal for Lifetime Achievement in Water Resources Research and Education by the university's Council on Water Resources. I think it goes without saying that her service record is exemplary and currently includes serving on many different boards, such as the American Water Resources Association and the Castor Joint Institute for Food, Water, and Energy Security. We're very privileged to have you with us. Thank you, Sharon. Take it away.
All right, thank you. And yeah, I guess you can hear me. I'm using the lavalier lapel mic. So it's very nice to be here today, and I'm going to watch the clock, and she's going to also time me, but I understand I have 25 minutes. And sometimes when I prepare a talk, I think, well, am I going to have enough to say? And then as I listen to everybody else, I keep thinking of more things to say. So I'm going to have a few prefatory remarks here, and that has to do with, or they have to do, in fact, is this working to advance? Oh. There you go. Okay. They first have to do with, so I'm the co-PI for this project from the University of Arizona, and as was mentioned earlier, we have a small team. You've met Simone, who gave a great presentation earlier, and DeBonker is going to be moderating a session this afternoon, and Isaiah's mentioned Kelly Thorpe. He's not really on our team at the University of Arizona, but he's working in Arizona, and we're a field site, a site for work, and what I'm hoping to do here today, according to what Isaiah wanted me to do, is talk about challenges in the southwestern United States, but with a focus on the Colorado River Basin and a focus on Arizona. Because one of the things Isaiah, Thomas Harder, and others know I've tried to do from the start is have people understand that our situation's different. There's a very large team of California people, and I would guess keeping up with California alone is quite difficult for people to do. And I try to keep up a little bit with what's going on in California, but we tend to know our states better. And I think it's important for a group like this to understand that there are differences in circumstance and so forth, even though some of the science may be the same and the techniques may be the same. So I'm going to focus on kind of informing you, I hope, in an interesting way of what's going on. And I have lots of maps to show you. But just a moment about the Water Resources Research Center at the University of Arizona. We're an extension and applied research center within the Division of Agricultural Life and Veterinary Sciences. An extension, it's like too many words, and the acronym is horrible. I direct the center. That's the sister center to the California, what is it called, what Doug Parker had headed up, the Water Resources Institute or whatever. We're part of a national network, but we all have our own personality, and ours really focuses a lot on engagement. We do conferences, we have publications, talk about QR codes. I've started now using QR codes in my presentation. They're really easy to create in Chrome. If any of you just right-click it or left-click it, and you can create a QR code. So I've started using them, and I have a lot of links in my presentation, so I try to make things accessible so people can find it. But we do interesting things, and it's all very real-world connected. I myself focus on water policy and management, and I teach a graduate course called Water Policy in Arizona and Semi-Arid Regions in the spring semester. And this is a slide that I use in the first class, and I use in many of my presentations, like I'm using here today, is what we see in water policy and management will reflect a lot of different factors. And I underline a couple of them here because they're really important, and you've already gotten a flavor of that, but just to underscore, things really depend on the legal framework. What's said in the law? Our law in Arizona doesn't recognize the connection between surface water and groundwater. May not make sense from the natural system, but that's what is. And then another thing is who's making the decisions? How centralized is that governance? We heard about the importance of governance earlier. It's extremely important. And we were talking at our table about Texas. Texas is, a big state with extremely decentralized governance, and other, the European Union, in my opinion, is more centralized in its governance of water than we are in the United States, across the United States. And then all those other things. But the importance of context is there. Of course, I have the water cycle context. But I want to talk a little bit about the geographic context, particularly as it relates to the Colorado River Basin. It relates to California and my state of Arizona. So this graph is a modified version of one that's used a lot, that was produced by the Bureau of Reclamation. This has some minor modifications, but they're not minor. They're not that noticeable, but they're important. But the physical boundaries are shown by the outline. But then, as you probably all know, Colorado River water is transported out the boundaries of the hydrologic boundaries to Los Angeles, San Diego, Denver, Salt Lake City, Albuquerque. And so if you just look at the land areas, and I just got back from Israel yesterday morning, and I was giving a couple different talks there. And so in the context of context, I compared the land areas and the populations. And Israel's like the size of New Jersey, which is the third smallest state. I grew up in New Jersey. And then look at Arizona's land area, and then look at the Colorado River Basin land area. And when you start looking at situations and possible solutions, the scale really does make a lot of difference. All right, and then there's different ways of looking at the basin. That map on the left shows the Colorado River Basin boundaries, showing the tribal nations. There are 30 tribal nations within the Colorado River. Several of them span multiple states, and the indigenous nations are going to look at things a bit differently than, let's say, state governments. And then this map on the right is a water map poster that we put out at my water center, and I'm going to blow up a couple of maps from there in a moment. And then another context that I've been talking about now for over 5 years is this wicked water problems context. And that is, we're dealing with big issues. They're not going to be solved. They're going to be mitigated. They're going to be addressed. If you start moving toward a solution, you're going to find things change, and you're going to constantly have to be adjusting things and adapting. And some of the reasons for that are listed there. And somebody talked earlier about all the different opinions and so forth, and getting people on the same page is very difficult. Often these issues are connected with other problems, poverty, geopolitics. You can put water in the big context of climate change. And so I like to talk about this framework because it enables me to tell people, and I give talks to regular audiences, not a bunch of academicians or researchers and so forth, to say, these are hard problems. Don't expect them to be solved and to be solved readily. And for academicians, it's like, well, interdisciplinary work is really required for these things. And so it really is important that we come out of our silos and work together and working on this kind of project and things that many of us in the room are working on. And then the final point, and I'll come back to this later, is process is important. So what's going on in the Colorado River Basin is clearly an example of a wicked water problem. It's the imbalance of supply and demand is just huge. And I have this photo that was on the cover of Municipal Leader magazine in April, just showing, what's happened to the level of storage in the reservoir, Lake Mead. And, in the last 6 months or so, the nature of what people, public officials and others are saying has really taken a marked turn. It really had been, yeah, don't panic, we're doing okay. Now they're saying, this is a crisis, this is a problem, we really need to worry about it. So the whole nature of the discussion is changing. And in fact, this was something from October 12th, CNN Online. You know, Interior Secretary says the West drought is one of the most significant challenges facing our country. I don't know how many read that. I think we in the West have a bit of a problem influencing or educating our elected leaders nationwide that a long-term drought is a serious problem. It may not be as dramatic as flooding or tornadoes or big storms coming through. All right, so this graphic here, and I have it from 2 months in a row. I usually don't do that, but I did it. This gets put out and maybe massaged a little bit by agencies throughout the Colorado River Basin based on reports from the Bureau of Reclamation that puts out every month a 24-month study looking at the status of storage and changes in storage. And I think, was it Felicia who mentioned, or whatever, you know, and I've been talking to too many people and listening to too many talks, so I'm not sure if it was said already, but you have storage in a system that's about 25% of capacity. I think somebody said this morning, it's the lowest it's been ever since the reservoirs were full. And you're talking about Lake Mead, the largest reservoir in the country, and Lake Powell, I believe, the second largest. And so these teacups show the relative size. And what was interesting and why I put in the two of them is that it looks like actually Lake Mead and Lake Powell went up a little bit, but you still have a very, very bad system. There was some good rain actually in the early fall, late summer this year. And so this is problematic. It's problematic not only because there's not the water in savings to draw from, but if you've read the news, you know that power generation is being is potentially compromised. If the water level goes down too much, it will be compromised. And the nature of the discussion is changing so much because, you know, we've talked already some about water rights and so forth. There are, let me see if it's on the next slide. Yeah, I want to talk a little bit about the different zones of agriculture in Arizona. So this is the blow up of the Water Resources Research Center's water map poster. And the green areas, let's see, the green areas show where there's agriculture. And we have different zones. We have the Yuma zone that usually relies on surface water, high priority in the system. This is the Colorado River Indian tribes that has a tremendous amount of water from the Colorado River available to it. We've got a little bit up here. It's increased actually some since this map was produced about 5 years ago. This is the area of focus for our study here, this Pinal area. It's between Phoenix and Tucson. And I had the population earlier. The population of Arizona is about 7.2 million people. More than 4 million of those people live in the Phoenix metropolitan area, and the Phoenix city itself is the 5th largest city in the United States. So you're talking about, you know, major populations, major activity. And we've had some agriculture growing up. There are different zones in that this is surface water dependent, non-Indian as we would call it. This is Indian agriculture. In central Arizona, you have a lot of non-Indian agriculture, but you also have growing and in some cases very stable Indian agriculture. And out here, this is all, and this has been dependent on groundwater and surface water. Out here, it's all groundwater dependent. So you can't, you know, just talk about what's going on in Arizona agriculture without saying what area of Arizona are you looking at. And those are just some figures. Agriculture uses about 72% of the water, and that up there on the upper left shows the sources of the water. And so we're still quite dependent on groundwater, and with the surface water diminishing, that dependence is increasing, relatively speaking. And then this map over here, I didn't make it too big, but the white on this, you talked about the white lands. Where's Stephanie? These white lands are the private lands. There you are. That's the private lands in Arizona. We have so much that's federal lands, state lands, and tribal lands in the state. The green are tribal lands. All right, so in 1980, the legislature and our Governor Bruce Babbitt adopted the Groundwater Management Act. And, you know, our experience with the Groundwater Management Act has influenced SGMA quite a bit because Governor Bruce Babbitt was, and former Interior Secretary, was an advisor to Governor Brown here. And so I don't have time to go through it all, but basically it established these active management areas and irrigation non-expansion areas where groundwater would be managed. So you have groundwater managed in the more populated areas, and again, this area here, the Pinal AMA, Active Management Area, is our area of focus. It established statutory management goals, and actually this is the one that doesn't have a safe field goal. All the other ones had a balancing withdrawals with natural or artificial recharge. This one was more like a planned depletion. We're going to allow groundwater to be used to maintain the agricultural economy. Over 90% of the water used in that area was for agriculture, and preserving some for future growth. The adoption of the Groundwater Management Act was very important to the construction, the funding of building the Central Arizona Project. And the Central Arizona Project is, this is a slide I used obviously with an international audience where I try to talk in kilometers and metric, million cubic meters, but it's 336 miles long and it goes up to an elevation of about 2,800 feet. And so it takes water from the river and pumps it uphill into Central Arizona. But in order to get the funding, this is where we had to agree that the water delivered to the Central Arizona Project would be junior to any and all deliveries to California. Not all of Arizona's Colorado River water is junior to California, but the water delivered through the Central Arizona Project is. And so when there are cutbacks, we are vulnerable, we are affected, and we're in the world of cutbacks triggered by 2007 guidelines. And again, throughout this, I'm putting up various links and stuff. If anybody wants to go read things, you can find it. And presumably our presentations will all be posted and it'll all be available to you. All right, something that was added after the Groundwater Management Act of '80 was a framework for doing storage and recovery, managed aquifer recharge. Our legislation doesn't ever use the term managed aquifer recharge, but that's the term used most places and certainly internationally. And so this has been a very important component of our water management strategies. We've been doing a lot of large basin infiltration, and the source water for that has been, wish we were there in that situation now, water from the Colorado River that we didn't have a need for to use it directly. And so we stored it for the future for times of outage and drought. We have many millions of acre feet of water stored in aquifers that had been depleted. So these are basin and range aquifers. There was a lot of use, and we've made a good use of this framework. And as Helen knows, that she's heard me give a talk, and I'll give a talk for AGU in 10 minutes or less about our framework and how useful it is. And I've written articles about it. You can read about it. But something that we've done here is AgMAR. I mean, we've been doing agricultural aquifer recharge by substituting surface water for groundwater use. So it hasn't been an application of like water in place of the groundwater. It's been used water in place of groundwater use. And so this is a picture of that. And I'm going to come back to that soon. Oh, my numbers, you got me all messed up with my numbers. I'm saying, why do those numbers look messed up? I tell students, and students in my class, always number your slides because it helps pace me to know how many slides I have and how much time I have. But also, if you have questions and somebody's going through a presentation, well, on slide 11, you said this and so forth. So now I'm not wondering why now I realize why those numbers are all messed up. All right. I want to show you some graphics. I had these maps put together recently by one of my staff just to help kind of familiarize people with what we're dealing with. So Simone in her talk showed a map of the active management area. I showed that. The county is different from the active management areas, so you can either map things by county or map things by active management area. But we have a number of irrigation districts, and the ones that are most relevant to our study are this very large one, just kind of southeast of Casa Grande, which is kind of the biggest city in that area. It's not huge, and this Maricopa Stanfield, and there's two others. But then notice these hatched areas. These are tribal lands. So we have the Gila River Indian community and then the Ak-Chin. Both of those do a lot of agricultural activity, but to do research with tribal nations, in fact, a couple of us just visited, our team and a few others just visited the Ak-Chin farms about three weeks ago. So there's very limited interaction between the tribal and the non-tribal agriculture. So just want to mention that, and we'll probably just have limited amount because we didn't have the opportunity to really go through the whole process of getting tribal nation approval. And this is looking at just the active management areas. And then this is looking at land ownership, just to get an idea of the land ownership. And so if you look at it here by the AMA, there's a large tribe to the south that goes into Tucson, the Tohono, but again, we've got the Ak-Chin and the Gila River. You've got a lot of state lands, you've got agricultural activity going on leased state lands, and then you've got private lands, and you've got the federal lands. So it's an interesting patchwork there. So what about groundwater? So this project is about groundwater sustainability. This project is about agricultural sustainability. With the management goal in that area and the status of groundwater, we can't really talk about groundwater sustainability. It's just not what we're looking at. What we're looking at is how can the community, how can agriculture be sustainable? What could change in order to enable sustainability and vibrancy of the agricultural activity for as long as desired. Some of the land, what I really wanted mapped was the actual landowners and try to match that to which owners were owning the land for purposes of development. Like they buy the land, they keep it in agricultural activity, the property taxes rates are much lower for agricultural lands, and they're really betting on future development because it's in what we call the Sun Corridor between Phoenix and Tucson. The problem is that a lot of that development was planned to occur on groundwater, and this is a cross-section from a model of the Department of Water Resources that was finished in 2018 that shows what their model shows for groundwater. And yeah, there's groundwater underneath these two irrigation districts. This is a cross-section, but it's getting lower and lower. And where the people tend to live on the ridges, where they live right now, there's not so much groundwater use. So basically, the Department of Water Resources said, based on this updated model, we are putting kind of a freeze on further issuance of certificates of assured water supply. We have a requirement for 100 years assured water supply. And so everybody kind of got in a state of panic. They formed a groundwater stakeholder group. I think I'm the only one on that groundwater stakeholder group that doesn't have a water right to protect or land to protect or whatever. But for some reason, they thought having the Water Resources Research Center was a good idea, mainly because one of my staff put out this visual guide and had been working in there. And so there's been a lot of work on the assumptions of the model, and you could, all you groundwater modelers, yeah, there's lots of assumptions. You can come up with different answers, but the thing I keep saying is the models don't produce more groundwater. And there's a big problem of lack of adequacy of groundwater. And so people really have to look at what to do for alternative supplies and using less. So we've done some good things. We've actually stored quite a bit of water in that area. This is an article I published in June about managed aquifer recharge. But something that's related to this Pinal area is that through those groundwater savings recharge efforts, we've cut down on the use of groundwater. We use surface water from the Central Arizona project, and groundwater levels have increased. But now the surface water for agriculture in that area has gone away because of the shortage on the Colorado River. And so, what does it mean when the agricultural, the water users can go back on the pump so they can keep using groundwater? They didn't have to give up their groundwater right. At the same time, you have these credits that somebody's got a right to recover. So you've got these two straws in the aquifer. So we've got problems. All right, there's lots of stuff ongoing. I'm down to my 1-minute warning or whatever it is here. And I think this is my next to last slide, but I have to get to my last slide because there's a little surprise on it. But there's a lot ongoing. This was something that I just took from the web just yesterday, I think. People are talking about, what to do. And, there's fallowing. It's estimated that about 50% of the lands in those central Arizona districts are going to be fallowed. They're looking at cropping changes. At Waiuli, there's some big studies going on. The university with a partnership was just awarded a big Department of Energy grant for working on this alternative rubber. Irrigation methods, there's a lot of testing going on with drip. There's some drip already being used. Other projects like photovoltaics. I was just in Israel. This is an installation in the Arava Valley of using an approach to photovoltaics that was developed by Greg Baron-Gafford, a professor at my university on that. So there's a lot going on, and we'll be working on this project and working with the growers and doing the kind of analysis that Simone described, but it's just so much going on. I can't tell you how many requests I get from students who are studying this all over the country and sometimes the world, because everybody's aware of the Colorado River. It's iconic. Just my last, I'm out of time. These are some of the things that back to process for these wicked water problems, and I like to highlight the answer that was given. This was before COVID, about what contributes to partnerships and progress, and it's eating with your partners, and we hadn't been able to do that for a couple years. And now we're finally discovering how tall people are or how short people are. I mean, it's really kind of weird. Like Steve, it's like when I met him last night, it's like, you're tall. So anyway, it's kind of fun. But I wanted to put up that photo. Those of you who know Yael, she moved back to Israel. I see a hand going over the heart. When I was going to be down in her neighborhood, so to speak, it's like I have to see Yael. And so I did get to meet her in person, which was great. And I also met Oren, her husband, and they're really, they're doing great things there. So thank you.
Thank you so much, Sharon. And we can take a question or two maybe kind of quickly before moving on to our next two technical sessions. Questions for Sharon?
This one back there.
Did you at the conference or just in Arizona, anything on this concept of solar panels and cropping underneath it?
That's what I showed in the photo. That's what the agrivoltaics is. I was out of
Okay,
time.
I couldn't see that.
Yeah,
So
yeah.
are they doing some of that in Israel?
They're just in a very limited way.
Okay.
I mean, that's a research site looking at
okay.
different crops, different soils, and a lot of that is not yet. It's being researched. It's not yet large scale, but it's kind of everywhere. They're talking about it now, and I think there's some great potential there.
But I think it's not for extensive crops. It would be more for lower acreage crops, that are grown more
it
vegetable
could have.
or something.
It could have. One of the problems with solar in general is connecting it to the system and having it be, usable. In this Castor Joint Institute that was mentioned, we're actually trying to take it out to areas that are off-grid, where they actually could make use of limited amounts of the power right there. But there's lots of potential to it, for sure.
Thank you.